Hi, and welcome back to Waveform Science. I'm Jeff Hagan. Today we're going to do an in-depth technical review of Bluetti's B80 battery. This battery it's already out on the market. You can already buy it, although it's only been out for a month or so. So why am I doing a review now? Well, we did a review of the AC60 head unit that this battery matches up with right around the time when the device was announced. At that point, the prototype unit of the battery had not yet arrived for review. So it took a couple of weeks after that before the battery arrived for me to start poking at. And then the testing took a little while. I have not seen other reviewers that have decided to really go into the battery, both as a standalone device and as attached to the AC60, so we're going to do that. In this video, we're going to be presenting 1,200 plus hours of discharge testing, plus other testing, and comparison to other Bluetti devices, bringing us up to a total of about 2,600 hours of testing across all devices mentioned in this review video. So yeah, there's a little bit of testing that we do today. So the battery itself was provided by Bluetti. I'll call that out ahead of time. This isn't something I could buy because I got it before it came out. If I didn't, I wouldn't have been able to complete this testing in the time that it was done in. So first off, what comes in the package with it? Well, you get the instruction manual, nice paper instruction manual, and you get the battery connection cable, which we're going to cover how to use a little bit later on. And that's it. That's all that's in the package. Nothing else in there. The specs on the battery itself. All of Bluetti's batteries, this one included, can be used in a standalone fashion. So it doesn't have to be connected to anything. I can turn it on right now. It turns on just fine. It's not even plugged into anything. So you can both charge it and you can discharge it, and you can run stuff off of it as a solar generator in its own right. With nothing else attached to it. It's got a solar controller on board, so you can recharge it from solar. And it's got power outputs, now DC only power outputs. But that's actually one of the strengths of Bluetti's batteries standalone, is that you can use them without the head unit. But we've done testing both with and without the head unit. Battery capacity, by the way, it's printed, silk screened on here, 800 watt hours. The manual actually says 806. So it'll be interesting to see if they decide to change the silk screening on the battery to say 806 instead of 800 as things go on. But we're going to go through the battery, both connected and disconnected from the head unit, and see whether or not it's useful. Size and weight. B80 battery is about 11 by 8 by 8, roughly. The battery is going to be more energy dense by volume than the solar generators itself that it would be used with. Actually quite a bit more dense by volume. The batteries themselves are more dense by volume because they don't have as many components in there except for the battery cells, which makes perfect sense. The battery weighs in at 21.9 pounds by my scale. Interestingly, 21.8 on the specs. The energy density by weight for the batteries is also significantly better than the energy density by weight of the associated solar generators. Again, because the external batteries don't have an inverter, so they have less parts in them, which means they have more percentage of the weight that's devoted to the battery cells. Which means that if you have an AC60 and you want to have more power added, you'll get more power in less space by adding another battery versus buying a whole nother solar generator. Let's take a quick look at the external characteristics of the B80 battery. First off, on the front, we've got the controls. We'll go through those in a moment. We've got the solar input. We're going to test that in a moment. On the first side, we have nothing. No air vent either, by the way. Nothing at all. On the back, we have nothing. There's no lamp on the external battery and no air vent. And on this side, we have the battery connector. This is, by the way, a different connector than is used on the AC200, AC300, and AC500. So this is a connector that so far Bluetti has only used on this one battery. It's significantly smaller, and the battery itself is smaller, so it does kind of make sense to use a different connector here. We also have a breather hole that's used for the waterproofing. On the bottom of the device, plastic thing closed up, we have plastic feet and the sticker. And on the top of the device, we have just empty. There is no wireless charging pad. We do, however, have a nice handle, folding handle, that makes it easy to pick the device up and move it around, similar to the AC60 itself. And by the way, the top of the device, the handle is flush. So it's nice and flat on top. You can stack stuff up there when the handle is in the stowed position. So turning the battery on, we've got a power switch here. Unlike the B230 battery and the B300 battery, the AC60's B80 battery turns itself on and off automatically with the head unit. So if you have it in a connected fashion and the head unit turns on because solar charging comes in or it plugs into AC, the battery turns on its own. If the AC60 turns itself off, eco mode, the battery will turn itself off as well. You can use the battery standalone to do that. You push the button, it turns it on, tells you how much charge is in here. We have the DC button that controls these ports right here. So let's turn those on. First off, we have a cigarette lighter port right here, your standard port. Let's find those on pretty much everything. The 12 volt resting voltage is about 13.5 volts with no load on it. Drops to about 12.5 volts with an 8 amp load on it. Drops to about 12.1 volts with a 10 amp load on it, and this is a 10 amp rated connector. Between 10.4 and 10.5 amps is where the voltage drops to nothing. So you can actually get a little bit more than the maximum rated out of this connector before it shuts down. Now you do have to be careful there because there are cigarette lighter adapters that would plug into this jack that are not rated for 10.5 amps. So don't get the cheapest adapter you can find and then expect to pull full power through it without melting the adapter. That would melt the adapter, not the socket, by the way. The socket is rated for that. USB-C port. USB-C power delivery port here. It is, in fact, a 100 watt, technically 105 watt, PD PPS port. And you can actually pull 100 watts from it. A little bit of loss in my test equipment here, but you can actually pull 100 watts from it. Same thing, we got a USB-A port. An advantage, by the way, over the AC60 itself, this one is a quick charge port. So variable voltage 18 watt quick charge port. So if you have an Android device, it will charge a little bit faster off of this quick charge port than it would charge off of the main AC60 head unit. It is, in fact, it tests out as an 18 watt quick charge port. And at 9 volts, you can pull 2 amps out of it to get the full 18 watts. And note that I have about half a volt of loss in my test equipment here. Methods of charging for the B80 battery. Well, it can definitely be used standalone without the main unit. There are 4 ways to charge it. The first way, of course, being to connect it to the main unit. It'll recharge directly from the main unit from the aviation port on the side here. Second way, if it's not connected, you can get a cigarette lighter adapter to DC7909 adapter cable. This is not in the box. Bluetti does sell these. You can find them on Amazon as well. But it's not in the container with the device. And that will allow you to recharge from the car. Or another solar generator's 12 volt output, by the way. Secondly, you can use this adapter. This is Bluetti's T200S adapter. This is what comes with the EB55, the EB70, the EB70S. That series of solar generators comes with this in the box. Or you can buy the adapter. For a reason that I don't fully understand, it's not on the Bluetti Power website, but it is available on their Amazon store and often on their eBay store. And that will plug into this port right here, and it will charge it at around a little bit under 200 watts, but around 200 watts. Next way, of course, be solar charging. It's 12 to 28 volts, 8 amps. And that, again, plugs in right here. That's recharging, and let's benchmark out the solar. I've got the B80 set up here, currently plugged into my very large power supply, and we're going to measure the solar charging response curve. So first off, the B80 itself is turned off. I'm going to demonstrate without even pushing the power button that it does turn on from solar. So that's a pretty common question. Turn on my power supply here. I am at 3 volts, 3.1, 3.0 volts, very, very low voltage, and basically no current coming out of it. At 3 volts, the device doesn't turn on. So let's up the voltage here. 10 volts, still doesn't power on. 11, right around 11 volts. That's where it turns itself on. So if you've got a solar panel plugged into it, it will, in fact, turn on its own without you needing to do anything. And we'll do that when the sun comes up. But at 11 volts, I'm still at no current. 0 current at all. Let's keep giving it some power. Right around 12, it starts pulling some power. 1 amp. So not a whole lot of power being pulled here yet. But let's keep going up. 13, roughly, 12.8. There we go. That's about car voltage, car battery voltage. 6 amps at 13 volts. That works out to about 100-ish watts. There we go. Jumped up to 7.2 amps. Let's go up to 14. About 8 amps. And this meter tends to run a little high, by the way. I measured it previously with a more accurate meter. 17, around 18, 19 volts. That's a normal single solar panel. Again, peaking out at 8 amps, which is exactly what it says it should do. 19 volts, 8 amps, 150-ish watts. Get up to about 22, 23 volts. There we go. That's one of our larger solar panels. A more premium type panel. Still pegged out, 8 amps. And that is giving us about 170, 180 watts roughly. 24 volts, 25 volts. And right about here, you can see my current starting to go back down. That's where I'm maxing out the input. So when I get above 25 volts, that's what it actually takes to cause this device to pull full maximum power. Now I only have up to 28 volts, so I have the same problem that I have with a lot of the smaller Bluettis, is that it's very difficult to find a panel where the open circuit voltage is 28 volts or less, and the maximum power voltage is 25 volts or higher. So we have exactly the same trouble we have with other devices, but it is what it is. 26, 27, 28. That's the rated maximum. It's 28. Let's see where it drops off. 29, 30, right there, 30 volts. That's where it drops down to 0. And here's what I measured earlier. Voltage rate, there is a little bit of a peak between about 25 volts and the maximum voltage allowed, where you can actually peg out the maximum. And then here's what it looks like compared to the input on the AC60 itself. And you can see it is in fact a little bit smaller than the input on the AC60. My guess is the slightly smaller input curve is based on the fact that the AC60 has better cooling. It's a guess. I don't have an exact reason as to why it's smaller, but it is a tiny bit smaller. So if you only have one solar panel and you're going to be plugging it into a combination of a B80 that's plugged into an AC60, plugging it into the AC60 will get you a tiny, tiny bit of extra power. But it's not a big enough issue to make it even worth worrying about. So adding a second panel will basically double your power, and we're going to be demonstrating that in just a moment. The B80 battery is designed to be paired with an AC60 as its main control head, and let's show you how to connect the two. So this cable here comes in the package with the B80 battery. This is, by the way, a different cable than the one that comes with the B230 and the B300 batteries. You can see here that there are 2 power pins and several data pins inside the cable. So this is not a cable that is just a couple of power pins. There's smarts in this too. And interestingly, it comes with these heads that kind of screw on to make the cable, I guess, have a dust cap on the cable. I guess that's what that's for. Okay. Now how this actually plugs in is you put the battery so that you can see the connector right there. And we put the AC60 so we can see the connector right there. The cable has a arrow on one side. See the arrow with the lock. And on the other side, it does not have an arrow with a lock. So you want the side with the arrow with the lock to be on top. So that's facing the ceiling at this point. Open up the connector and you simply push. You'll hear it snap in. Same thing on the AC60 itself. You get the side that has the arrow and the lock. It goes facing upward and it snaps into place. Does an AC60 with an attached B80 battery charge any faster with dual charging, in other words solar and AC, versus just AC? So here's my experimental setup. I have 2 of the T200S power adapters plugged in now, one to the battery, one to the main unit, and I have AC plugged into the main unit. First, let's turn on the AC, wait for the system to power itself on. And we're charging. Charging at about 500 watts from the AC wall power. Now I'm going to power on just one of the 2 T230 adapters, or T200 adapters, excuse me. Powers on, wait for it to charge. Doesn't go any faster. Well, a little bit. Not a lot, a little bit. Let's power on the other one. Now that's interesting. Quite a bit faster. So we've gone from 500 watts to 700 watts, so 200 watts faster, which tells me that this adapter here is definitely doing something. Also, another interesting note, they fixed this from the AC200 Max, AC300, AC500. All of those devices don't show the input power from the battery on the main screen. This one is definitely doing that. Let me demonstrate. I'm going to turn this off. So now this charging brick is off. And I'm going to turn off the AC wall power. So my AC wall power is now off and, by the way, unplugged. So the only source of power at this point is this charging brick, and it's showing it on the screen. So, very cool. If it works with one B80 battery, does it work with 2? And the answer is, let's find out. So, turn on the power here, AC power. Same setup, by the way, just this time there's 3 of the T200S adapters. AC wall power, we are in normal mode, standard mode charging. And a little bit over 500 watts. By the way, the charging on the AC60, a reminder from the AC60 video, is thermally limited, so it will slow down a little bit when it overheats. But, interesting note, if I'm charging at 500 watts, and I've got 400 watt hours of battery cells, in other words, one AC60, there's a certain rate of power that's going into each cell. When I start adding more battery cells, but I'm still charging at 500 watts, the charging rate per battery cell, given that the input power is exactly the same input power, is actually less power per cell because I've added more battery cells. What that means is thermally limiting the system is less of an issue. So you're going to see a lot less thermal slowdowns due to charging due to heat while charging when the external batteries are connected. So I've actually measured this out. So silent mode takes 3 hours and 15 minutes, exactly the same results as my AC60 video. When you add the two B80 batteries, you get 16 hours for silent mode. So that takes a while, but it is a nice, slow, even charge. Standard mode charging, I get 1 hour and 54 minutes from the AC60 on its own. When I add the two batteries, I'm up to 4 hours and 49 minutes. But notice that the speed of charging goes up from about 250 watts all the way up to a little bit over 500 watts. That's measured from the wall, by the way, not what it says on the screen. With the batteries attached, and there's basically no thermal issues. Turbo mode. The AC60 alone on turbo mode will do it in just about an hour. But you can see there's quite a lot of thermal scaling in the charging process. It peaks up a little bit over 600 watts, and then nearly immediately has to slow back down because it's gotten too hot. And this, by the way, is with an AC60 that started completely cooled. I let it sit overnight for this test to make sure that I was giving the thermals a good chance to do their job. But when I attach the two batteries, I get an over 600 watt charge rate measured from the wall, and it stays there the entire time, rock solid. So it does take 4 hours though. All right, let's flip it into turbo mode here and demonstrate just how fast we can go. So we've got it in turbo mode, we've got the two attached batteries. I'm going to turn on my AC power back here. There we go. It's going to pick it up and it's going to start charging. And we bumped up to a little bit over 600 watts. Just as predicted by the graph, and we're going to try dual charging. We're going to see if we can go beyond turbo mode. So first I'm going to take this T200S adapter, just this one that's plugged into the head unit. I'm going to turn that one on. And we do get faster. I'm all the way up to 800 watts now. And that's just this brick on. These two aren't on yet. Now I'm going to turn on just one of these two bricks. Just one of them. Murphy's Law, it's the back one, but that one's on now. A second to start charging. There we go. Now we're up to 980 watts. Let's turn on the second one here. And the green light, wait for it to go red. That's my wattage. Now the fan kicks on. We are now looking at approximately 1200 watts into an AC60 with two attached B80 batteries. And that's a nice speedy charge. So the graph of this, beyond turbo mode, you'll see at the bottom I've got the normal mode in red, and in yellow I've got the turbo mode. Above that in gray I've got one T200S adapter that's going to the main head unit. And then above that I've got two T200S adapters, that's the green line, and then above that I've got the blue line. Now, how bad is it for the battery to do this charging? Because I'm going way beyond the limit of the standard AC input. That's got to be bad for the battery, right? Well, not exactly. Because again, remember, the more battery cells I have, the less wattage per battery cell. So the way to measure charging like this is called the C rate, which tells us whether or not it charges in X number of hours. So if I charge the same battery in 1 hour versus charging that battery in 2 hours, charging the battery in 1 hour is going to be much harsher on the battery. We can see even with all this power in here, and 52%, I'm at 1.2 hours. My graph says it's going to take slightly over 2 hours to charge this whole unit with all these adapters connected in turbo mode. But if I take the AC60 alone, standalone, no batteries attached, from the AC60 video that I did previously, and I put it alone in turbo mode, it's going to charge in just about an hour. So actually using turbo mode on the AC60 without the external batteries is harder on the battery than this entire setup with all the external chargers. So it depends on the size of your battery. As you make the battery larger, it takes more chargers to overload the system. Let's go ahead and turn off the external chargers here. Now that does make some noise. Here I've got some fans kicking in. Let's explore that next. So right now I have the device still set in turbo mode. I'm still charging at 600 watts, and I have the sound meter pretty close to the device here. .58, 59 decibels. Interestingly, pretty much exactly the same as the AC60 standalone test. A significant reason for that is, if you notice, the B80 batteries don't have vents on the side of them, which means there's no fans in them. So they don't tend to make a lot of noise. Now, where it gets a little bit noisy is when I turn on all these T200S adapters, because they each have fans in them. So let's do that and see how bad it gets. That's about as noisy as it gets. 64, 65 decibels. It is pretty noisy, but consider how hard I'm driving this thing right now. I am charging it way beyond the levels that most people do. As you all know, I do enjoy doing detailed battery efficiency comparisons, but one of the real challenges with the B80 is what to compare it to. Standalone, the B80 can't really easily be compared to one of the other solar generators because it doesn't have an AC inverter in it. It only has the DC side. So I think the thing that makes the most sense to compare it to is the B230 battery. This is an 800 watt-hour battery. This is a 2048 watt-hour battery. So this is more than twice the size. So generally, as solar generators go, when you get bigger, you get less efficient. Now, the B230 battery does have outputs on it. Right here, I've got a DC output, a cigarette lighter jack. I've got USB-C output, so that's a good thing to compare it to, because the B80 battery has the same thing. I've got a cigarette lighter jack output, I've got a USB-C output, and I've got a USB-A output. So let's run those numbers, which of course takes a while. But kind of as expected, the B80 battery is more efficient than the B230. In fact, quite a bit more efficient, surprisingly so. Bluetti tells me they hold about 10% of the battery in reserve to prevent the battery from going to zero, and we are getting 90% or slightly above 90% ratings. So that either means that they are holding slightly less than 10% of the battery in reserve, or this battery has near perfect efficiency. So that's actually really cool. This is a very, very efficient device. So let's take that battery efficiency and let's just leave it running for a while and put a very small load on it and see how long it takes to drain itself. The way that I do this test is I hook up a 7.5 watt load, very small load, and I assume that any power that didn't go to the load must have gone to the battery itself internally. And I let it run until the battery goes completely dead. Now on the B80 battery, this took multiple days. But the B80 battery came up with 0.99 watts of internal standby power. That's really good. And that is, of course, assuming that they hold 10% of the battery in reserve. So if they hold a little bit less than that, my numbers will be off by a little bit. But I did try to double check with Bluetti to see what they hold in reserve. So assuming 10%, it uses about a watt to keep the thing on. The B230, by the way, uses about 5 watts just to keep the thing running. And the B300S uses a little bit over 5 watts. So very, very good standby power inside the B80 battery. And that's actually going to affect the discharge efficiency of the B80 when attached to the AC60. You folks know that I like my detailed efficiency charts where I take the device and do lots of discharge testing. Well, in this particular video, I didn't just discharge test the B80 battery on its own. I also tested it attached to the AC60. And not only did I do that, I did the whole thing all over again from starting with 2 B80 batteries attached to an AC60. So I was able to test the entire setup in all combinations so you can get good run times for how long things will last, with or without however much hardware you decide to buy. So first, here's the AC discharge efficiency curve. Interestingly to note, the more batteries you add, the more efficient it gets. How does that work? I add more hardware and it gets more efficient. Reason is the battery itself on its own is so much more efficient than just the AC60. That the efficiency of the battery, also notice the battery is twice the size of the AC60 in capacity. So the more batteries I add, I'm dragging the efficiency numbers up because a smaller percentage of the entire unit is the AC60 head unit. So when I add more batteries, I get better efficiency. Kind of cool, actually. Additionally, because the inverter doesn't get any bigger, the actual discharge rate from each individual cell is less. Because if I pull 600 watts from the cells that are just in here, I'm going to be pulling them at some rate from each individual battery cell. Now if I take that same 600 watts and I pull it from all 3 of these, well, there's a lot more battery cells sitting here. So the amount of power that's going to be coming out of each individual cell is going to be a lot less, which means the cooling requirements for those each individual cells are going to be a lot less because they're not being worked as hard. So similar to the other modular power stations, if you're going to operate it near the high end of the inverter capacity, it's actually a lot easier on the batteries if you attach more capacity to it. But you're looking at, with a single AC60, you're looking at about a day at 7.5 watts, and with 2 batteries, you're looking at about 4 days. That's pretty good. That's actually really good. And that's AC. That's with the inverter running. Up to 600 watts, biggest you can get is about 3 hours at 600 watts off of this unit, but it's not really designed to be a high current draw unit. This is a low power, runs for a very long time unit. Let's take a look at DC. And before we do, by the way, one thing I want to note, we do have 3 cigarette lighter ports here. So when you add another battery, you get more DC outputs. So you'll actually see this on the chart in a minute here. But one thing I do want to call out, this DC output is not connected to this DC output internally, which is not connected to this DC output internally. This is not one big DC circuit where you can run all 3 of these into a DC bus and have them working in parallel. This is 3 separate DC outputs. So that does make, if you're going to use an AC60 and wire up an RV in it, that does make it a bit more complicated because you don't have one 30 amp output, you have 3 10 amp outputs. And you'll have to figure out how to wire things up based off that. But the more batteries you add, the more DC you get, which is kind of nice, actually. So with a AC60 standalone, you can get 100 watts from here and 100 watts from here. And I don't measure the little USB ports. It's not worth adding those in. But I can get up to about 200 watts. And when I add in one B80, I can get another 200 watts because I have another cigarette lighter, another USB-C port. And when I add a third B80 battery, I get another cigarette lighter and another USB-C port. So I can actually get up to about 600 watts of DC out of here. And at max, again, we're looking at about 3 hours and 10 minutes. That's with all 3 units connected to each other and pulling the full 100 watts from here, 100 watts from here, 100 watts from there, 100 watts from there, etc. That gives me 3 hours and 10 minutes. But at more realistic loads, somewhere in the 40 to 60 watt range, which is what you'd see if you were going to use this in a camper, we're looking at greater than a day of runtime at a low power mode, and that's with no solar connected. So that's really good because that's really what Bluetti designed this system for. This is a low powered, you need a bunch of capacity, You need way more capacity than any of their standalone units, but you don't really want that big of an inverter because you don't want the high load. And the DC circuits themselves are also smaller, so you get a lower standby use power on the DC circuits as well. Let's compare this to a couple of other Bluetti devices. So first off, the bigger one, an AC200 Max. Let's compare it to that. AC200 Max is the same capacity as an AC60 with two B80 batteries, roughly. So we're kind of comparing apples to apples here. Except, of course, that the AC60 has a far smaller inverter. And if we look at the AC discharge efficiency, it's incredibly obvious. Small inverters are much more efficient than large inverters. The AC60 is far, far, far and above more efficient than the AC200 Max on the entire curve. So if you're looking for efficiency, absolutely the AC60 blows the AC200 Max out of the water, with the exception that it can't run anything bigger than 600 watts. So understand the limitation there. Let's look at DC. The AC200 Max does have the 30 amp output port, a single 30 amp output port. So that's actually going to give you a little bit over 400 watts out of that. And I didn't push it beyond that. I didn't also try the cigarette lighter and the USB-C ports on the AC200 Max, simply because the cooling was really, really, really struggling at the max current output of the 30 amp output port. So I decided not to push it, and you can actually see the efficiency starting to go down there on the AC200 Max at the max drain rate. The AC60 has no problem. It can go all the way to the end to 600 watts, and you can see the efficiency doesn't drop because the cooling just isn't working that hard, because the batteries are all in separate enclosures. It's got a larger physical footprint. But, the downside to that is, of course, it's 3 circuits, not 1. So you don't have one big circuit. You've got 3 circuits. So it depends on what you need to run. If you're trying to run, for example, an amateur radio, a ham radio, that has 26 amps of power that it draws, well, you're not going to be able to get 26 amps on a single circuit out of an AC60. You just can't do it. So you're going to lose some efficiency when you move up to the bigger unit. But if you don't need that, if you're running a refrigerator and some LED lights and the things that people tend to run while camping, recharging a drone battery, this is perfect for that, and you'll gain extra efficiency. Let's compare it to the AC180 AC. Interestingly, the AC180, being a newer generation model than the AC200 Max, almost keeps up with the AC60. In fact, at higher wattages, it does keep up. Interesting. So when the newer generation of inverters is significantly more efficient than the one generation back. But still at lower loads, at the 40 to 60 watt range, where this is really designed to shine, the AC60 is significantly more efficient than the AC180. And if you add 2 batteries to it, this particular graph has on 1 battery. If you add 2 batteries to it, you get significantly more efficient, longer runtime as well, because now you're comparing a 2 kilowatt unit to a 1 kilowatt unit. But in this particular case, I wanted to do apples to apples, so a AC60 with 1 battery is about the same size, about the same capacity as an AC180, so that's why I did that one. And we've got run times there. Now let's look at DC. AC180, kind of the downside of that unit is it only has the 1 cigarette lighter output. It doesn't have a big DC circuit like the AC200 Max does. The AC60 with 1 attached battery, again for apples to apples size comparison, does have the 2 cigarette lighter outputs on separate circuits. So I was actually able to pull 400 watts out of it using the 2 USB-C ports and the 2 cigarette lighter ports. And you can see that the AC180 is actually a little bit more efficient, interestingly, than the AC60. Probably because it's not trying to control an external battery. It's just got a little bit less in it on the DC side. A very common question that I get on these modular power stations is, what happens if we recharge it from just one of the batteries? We've got the AC60 hooked up to 2 B80s. At this point, everything is at 0. There's no charge in any of the system, 0%. I can bring up the app here and show you. So you can see the main battery here is at 0. I'm going to bring up the secondary batteries. and the secondary batteries are also at 0. So the whole system is completely discharged at this point. I'm going to take my T200S power adapter, as shown earlier. I'm going to plug it into one of the inputs here. There we go. And I'm going to flip the switch here and turn this on. And the purpose of this experiment is to see, does this one adapter that's plugged only into this battery and nowhere else, is that going to charge the whole system or just this battery? And we're going to find out. And yes, at 200 watts, this is going to take 10 hours. Since the screen isn't even going to stay on, because there's no way to get it to stay on, there's no point in sitting here and waiting 10 hours or making the video longer. So we will come back in 10 hours and we will see whether or not this has charged everything or just this one battery. Okay, it's been a little bit more than 10 hours here. Let's go ahead and unplug it. You can see that the units have powered themselves off automatically, except for the one battery that it was plugged into. This one is showing full. Let's turn on the main unit and see what we've got. So this one's full, this one is full, and the main unit is showing 98%. So yes, plugging in one port definitely charges all 3 units. This means that if you go camping and you've got a solar panel plugged in to the main unit on the side, you've got another solar panel plugged in down here, and your main solar panel winds up being in the shade, the solar panel that's plugged in down here will in fact charge the entire group. So very good thing. Well, we've gone through all the tests and pretty much everything I can think of to throw at the B80 battery and the associated AC60 when they're connected. So we've kind of gotten to the end. So what do I think of it? First off, what I like, the waterproofing. IP65 waterproofing, very good call on these. If you take them camping and you leave them charging and you get a light rain shower, you basically don't have to worry about it. Good peace of mind for this particular use case of device. It's very, very nice on that case. This may be the most efficient device of any solar generator that I've ever tested. The standalone battery, I've actually never seen one in this size class that has less than 1 watt of standby power. I mean, a watt of standby power, you're talking a pocket-sized battery bank tends to have 1 watt of standby power. So a device this large that uses that little power, that's pretty impressive. It's got onboard solar controller, where the previous generation did not, the B230. This is a lot easier to move around than a B230. It's got a lot less weight for it. So if you've got folks that need a solar generator but can't lift the weight, you don't need a cart for this. You can just pick it up and carry it. It doesn't weigh that much. And if you connect 2 of the B80 batteries with an AC60, you can get a unit as big as an AC200 Max, and by the way, you don't need a cart to move it around. That's pretty cool. What can be improved on it? Because of course there's always next steps after this. There's no such thing as a perfect product. I'm going to call out a couple of things. First off, the AC60 does have Bluetooth and can firmware upgrade the battery. The battery doesn't have Bluetooth. So if you're using a B80 battery standalone and you don't have the AC60 head unit, there is no way to do a firmware upgrade. Unless you find somebody's AC60 and borrow it for a few minutes and let them firmware upgrade it via the battery connection cable. So that's something that I really think Bluetti needs to think about going forward, is that the batteries need to be able to be firmware upgraded standalone. You also lose the app control when you're using the battery when it's not connected to the head unit. They've got really nice app control for the AC60. We covered it in our AC60 video. But the battery, the only way to look at the battery, so to speak, is to connect via the AC60. Now, that would add additional overhead to do that, because you're going to have to put a Bluetooth board in there. Those use power. You'll have to have a microcontroller that uses power. So we're looking at a slightly higher power usage to do that. But I'm completely okay with that. Honestly, I think it's necessary that you need to be able to update these things, very specifically firmware update. That really needs to be able to happen on its own. Undecided things. The battery connection cable. Bluetti has promised a cable that will connect to the B80 battery that will let you recharge, by the way, pretty much everything else they make as a daisy chain. That cable's not out yet. When that cable is out, we will have another video covering the B80 and specifically the use of that cable and what devices can and cannot be charged by it. Because I'm of the opinion that a significant use case for the B80 battery is to expand all of their other units. Because the voltage output on that cable is supposedly, if it is what they tell me it's going to be, within range of pretty much everything they make. So that'll be really cool. But it's not here yet, so I can't talk about it. It'll be around whenever it is that it's around. Overall, I think it works really well. The launch of the device seemed to be successful to me. I don't have their sales numbers, but it looks like people generally tend to be happy with them. I haven't seen a lot of issues floating up, early issues being reported on Facebook groups, where people are complaining that they're not working, so the people that are getting them tend to be liking them, or at least they're not complaining about them. And I've taken them out and used them a couple of times, and they do tend to work. So overall, I think it's a reasonably good device. We'll see how it fits into their lineup as time goes forward and how the market reacts to it. But it is highly efficient. It does the job that Bluetti designed it to do, and I think it does it very well. And with the exception of that one major nit that I called out, that is the lack of Bluetooth on the device, it's a very good device. So that's kind of what I think of it. As always, I will call out a disclaimer. I am not paid by Bluetti to make these. I'm not paid by anybody to make these videos. I do work in tech, but I do not work on solar generators. I do not make any money at all on my solar generator work. My YouTube channel is not monetized, and I won't turn on monetization. I make these videos because I enjoy making them and because you guys enjoy watching them. So as long as people keep liking the videos, I will continue making the videos. Thank you, and have a good day.